possibly one among Dr. Mahesh Gatala from CIMIT, and then again from IRI, Dr. S.P. Datta. I've been knowing all these speakers since quite some time. And the first speaker, as I see, Dr. Bhattacharya, he has been a wonderful worker and associated with the National Academy of Agricultural Sciences as well. Known for his work on the specific aspect of soil science, on the carbon sequestration and related issues. So without any further waste of time, I welcome all the three speakers. More so the first one, Dr. Bhattacharya from IRI. And let's see what we have in store from the speakers for the day. So with that, I wish the day a wonderful success through the listening from the three speakers on soil science. All the best.
Thank you, sir, for your encouraging words. You have been always giving us encouragement for conducting such programs. So now I will request our Honorable Dean Faculty Agriculture and of course the Head of the Department Soil Science, Professor Dibyendu Mukhopadhyay, to address this small gathering.
Good morning, everybody. Honorable Vice Chancellor, Dr. Chirantan Chattopadhyay, sir, respected speakers, Dr. Bhattacharya, the students, my colleagues, all the deans and the directors who will be among us during the sessions, and the very persons behind this type of webinar series for conducting is our Vice Chancellor. He's always encouraging us to conduct this type of seminar specifically for the students. We will have today 3 seminars that will be delivered by Dr. Bhattacharya, Dr. Mahesh Gatala, and Dr. S.P. Datta, as told by our Honorable Vice Chancellor. The basic plan of this seminar is that to contemplate the soil research and education during the coming era. We are venture for 2025 and onwards. What we have done as of now and what should be done. What are the research gaps in between? There are so many factors, particularly in our region of North Bengal. The soils are problematic. As you all know, that there are so many works that is going on during the last few decades or so. Still, it is quite apparent for us that the gap is there. So we have designed the webinar in such a way that the stalwarts will be delivering the lectures in that direction so as to find out the gap, and we will have to design our research program in that way. So as this is basically for the students, but we the faculties are also involved here, so that our research, further research will be framed to get some output specifically for the stakeholders, the farmers. And with this proviso, I don't want to lose much time because there are other speakers also. So I wish the seminar a grand success, and it will definitely give us an insight so that we can look forward for further research and education in the for the cause of the soil science. Thank you. Thank you.
Thank you, our Dean Faculty Agriculture and the Head of the Department. I will again request you to please kindly introduce our guest speaker, Dr. Ranjan Bhattacharya, please.
Thank you, Professor Sinha. Dr. Ranjan Bhattacharya earned his MSc degree from the Indian Agriculture Research Institute, New Delhi in 1998 and joined as scientist at Vivekananda Parvatiya Krishi Anusandhan Sansthay, Almora in 2001. He earned his PhD degree from the University of Wolverhampton, UK in 2009. He assessed the potential of hillland soils for yield sustainability and soil carbon sequestration through adoption of conservation tillage, diversified cropping, location-specific organic farming, site-specific land use management, and integrated nutrient management practices. He standardized conservation tillage, nutrient and water management practices under rice wheat, soybean wheat, and finger millet lentil system for soil conservation and carbon sequestration in the Indian Himalayas. He also identified novel conservation agricultural practice and nitrogen management in the Indo-Gangetic plains for higher productivity, water use efficiency, and carbon and nitrogen accumulation in topsoil under rice and non-rice based cropping systems. Development of pine oleoresin coated urea for higher nitrogen use efficiency, palm mat geotextiles for soil erosion control and higher crop productivity, buffer strips of palm mats in the UK, and grassed buffer strips for low-cost soil conservation, a lightweight zero-till ferticide drill for sowing of rice and wheat crops in the plots under conservation tillage are some of the pioneering contributions. Dr. Bhattacharya got several prestigious awards. He is a fellow of the National Academy of Agriculture Sciences, received Team Award in 2008-9 in Natural Resource Management from the ICAR, India, and got BC Dev Memorial Award from the Indian Science Congress. He was a board member of the International Soil Tillage Research Organization, ISRO, during 2015 to 2018, and received a scholarship award from ISRO during 2009. He is an editorial board member of Geodharma and Agriculture, Ecosystems and Environment since 2014 to date. He has published 93 international and 20 Indian national papers, 3 bulletins, 3 books, 18 book chapters, 37 conference papers, and has H index of 33 with 3,600 citations as on 2nd September 2020. Besides, recently, news has come that the Stanford University had published world's top 2% scientists. In that database, 32 ICAR scientists are listed, where Dr. Bhattacharya is among them. So I congratulate on my behalf and the team that it is a very prestigious award that you have got. And this has already encourages us for the future scope of research that we are citing for. So I have cut short this CV a little bit. But with this proviso, I request our convener, Professor Sinha, to start the main session. Thank you, Dr. Bhattacharya. Thank you.
Thank you, our Dean Faculty Agriculture and Head of the Department Soil Science. So now I may request Dr. Bhattacharya to kindly deliver his lecture. Sir, please.
Thank you, Dr. Sinha. Thank you, Professor Mukhopadhyay, my old friend of BCKV, Honorable Vice Chancellor, Dean, and all dignitaries. I'm just sharing. It is taking some time because it's a large file. It should open soon. So is it visible?
Yeah. Visible.
Thank you. So today's presentation mainly on soil conservation and carbon sequestration for sustainable agriculture. As you know, that only 11% of world's land is suitable for growth of crops. However, we have excessive erosion over the land, and you can see about 6,000 million tons of soil washed off India's cropland every year. So soil erosion is a quiet crisis. It happens very quietly, one that is not widely perceived. Unlike earthquakes, volcanic eruptions, and other natural disasters, this human-made disaster is unfolding gradually. And another thing is that, Leonardo da Vinci said, we know more about the movement of celestial bodies than about the soil underfoot. Because you can see that land degradation, if we talk about in India, soil erosion is the major problem, about 74 million hectares, and wind erosion. So soil erosion is about, we call it water erosion, and wind erosion in about 12 million hectares. Annual soil loss about 16.4 tons per hectare per year. So India loses about 13.4 million ton food grains every year due to soil erosion. Now, so soil erosion by water and soil organic matter loss are the major drivers of land degradation. Why soil carbon? Because 2 to 3 times or more carbon is present in soil than in the atmosphere. And you know that soil organic carbon is more than the ocean organic carbon. 1.4 billion tons of carbon could be stored annually in agricultural soils. This is a projection by IPCC. And you can see in the developing countries, 20 to 40 million tons of additional gains per ton of stored carbon in soil can be possible. So these are some soil and water conservation measures, and I'll be talking about some of these first, and then I will go inside into the carbon sequestration. So the first process of soil erosion is the splash erosion. This photograph is from China. You can see that how erosion, even in the dense cropland, happens because of the slope and high intensity of rainfall. So first of all, I discuss with the filter strip and contour buffer strip, because these two are the major technology in and people not well perceived as far as my perception is concerned. So filter strips are grass, trees, or shrubs that filter or clean runoff and remove contaminants before they reach water bodies or water sources such as wells. So other things are self-explanatory. Like, you can grow aromatic grass-based conservation farming in the Himalayas or in the foothills of Himalayas. And this paper published in Agriculture Ecosystem Environment, where we found that wheat equivalent yield increased due to this filter strip by 17%, and soil loss reduced by 33%, and moisture conservation was increased by 31% for wheat, which yielded about 7% more economy. So there the treatment was FYM plus vermicompost plus poultry manure plus minimum tillage with 3 weed mulch. And palmarosa is a major weed there. Now I coming into my own work. This is a European Union project in the UK where I did the PhD, and it's a global competition to for one PhD position, and I was selected. You can see the Queen is praising the project in one of our Lithuanian partners. This is a Borasas palm tree found in Africa, and this is a Bruti palm tree found in Brazil. So from these palm trees, the palm mats are not really used. So these mats, the project thought that if we can make mats out of these palm trees and then just put in the slope of the soil for controlling erosion. That will be a great service to the nation and the whole world. So my PhD thesis main hypothesis was complete cover by geotextile mats is unnecessary in the UK condition, where emplacement of boracious mats as buffer strips, just area coverage 10%, you can see from the photograph, decrease total soil erosion by 92% in arable loamy sands on a 15-degree slope at Hilton, United Kingdom. And you may be knowing these things published extensively in different international journals. We also found complete cover of biogeotextiles decreased soil erosion by water by 67 to 99% in diverse agroecosystem. This was published in Land Degradation Development. So another novel process to estimate the splash erosion under field condition was first time developed in this PhD thesis. The use of boracious mats on bare soil reduced splash erosion by 89%. So we targeted the first step of soil erosion. This is the splash plots at Hilton, UK. And then soil quality of eroded plots. Except for boracious completely covered plots, all plots increased topsoil bulk density and decreased aggregate stability, but maintained soil organic matter. So far, before 2009, people just measure soil loss and soil erosion studies. They not really measure the soil qualities. So we measured these and published 2 papers in Catena. So this is the result of splash erosion. You can see the boracious cover plots is having over 39 observations. This way we collect the splash. This is the measurement for the splash height, and about 90% reduction in splash erosion by boracious cover plots. However, Bruti, because of the land cover is less, Bruti mats were not so useful for splash erosion control. But later on, you can see that Bruti mats in buffer strips of Bruti mats also effective for soil conservation. First of all, the runoff volume. Runoff volume of the complete cover plots is little bit significantly higher than the permanent grass plots because of falling of raindrops on the mats and just rolling over without contact to the soil. But it is much less than the bare soils. You can see the similarly soil erosion rates significantly reduced by 98 to 99% in the grassed plots, which is statistically similar to boracious buffer strip and Bruti buffer strip plots. So from there we conclude that only 10% area coverage under that sort of climatic condition is very useful, and that will save a lot of money. Where the erosion rates are more and the slope is more steep, this picture is from Brazil. There the mats can be grown. If you put the mats, then slowly the moisture is conserved and the vegetation comes out, and this is a very good way of soil conservation. Now you must be thinking about the price. Yes, the boracious Bruti mats has comparable price to the other mats, but less than your jute and coir geotextiles. So in the project we also went for matched over geotextiles or huistro mat, matched over mats like that. So apart from Gambia and Brazil, we have the project in China, Thailand and Vietnam, where these mats were used. Now you will be happy to know that in India, at Dehradun, that Indian Institute of Soil Water Conservation, their cowpea based vegetable barrier they have created, and some weed or maize stover based vegetative barriers was created, and coir geotextiles also tested. So Dr. Ramanjit Singh is a scientist who is testing the geotextiles, and published also one paper in soil tiller research. I am also a co-author in that. So if you are more interested, you can visit. So another thing is that alternate land use systems for resource conservation. So you can see that different land use planning, like cultivated fallow, if you have soil loss 5.65 tons per hectare per year in a 2% slope at IISWC Dehradun. But other options, if you use, soil loss significantly reduced along with runoff, along with loss of nitrogen and potassium. Another important practice is your cover crops. As I said, the cover percentage is the major thing here. Cowpea, you can see cover percentage is about 90% compared to soybean, cover percentage is only 20%. So when we grow maize alone and maize plus cowpea, so in the maize plus cowpea intercropping system at 2% slope, about 18% reduction in soil loss and about 22% reduction in runoff. Even green manuring and mulch farming, reduce runoff and soil loss considerably when you see with green manuring, and this is without green manuring. So in the land slope, different land slope, when soil loss get reduced by about 5 tons per hectare in about 9.5% slopey areas. Likewise, mulching, you have control where mulch 2 tons per hectare and 4 tons per hectare reduced soil loss considerably from your 17.8 tons per hectare. Likewise, contour cultivation in Dehradun on a 8% slope. That contour farming is system of crop husbandry, which cultivation operations are done on contour. Example, tillage, sowing, interculture operations, etc. all are done in contour. And in contour cultivation, you can see soil loss get reduced. Now coming to some work of mine on soil carbon sequestration. Soil carbon sequestration is a win-win-win strategy that advances food security, improves the environment, and mitigates global warming. Carbon sequestration implying capturing atmospheric carbon dioxide into long-lived pools of carbon. And from the mass balance equation, 1 ton of soil carbon is equivalent to 3.67 tons of carbon dioxide, either sequestered or emitted. Now, this is a very interesting, why we should go for studying carbon pools and carbon, sequestration research. You see a land, clear for native vegetation in some 0 years, and about after 17 years, you can see the constituents like 8% particulate organic carbon and 63% humus, and say 27% resistance or recalcitrant carbon. And say after 32 years or so, when soil organic carbon reduced, then the land managers again converted it to permanent pasture. And you can see about say 42 years, the carbon is similar to the carbon of that 17 years. But this carbon is having different composition. This has 26% particulate organic carbon and reduced humus by 244%. Okay, although the recalcitrant carbons was same. That means this carbon is more degradable, more liable to be lost under a climate change scenario. Now that's why, like our body is having cell, soil is having, I call it a cell like aggregates, and this is we call it a macro aggregate or a large macro aggregate, more than 2 millimeter diameter. Inside that large macro aggregate, there are small micro aggregates. Micro aggregates, apart from sand, silt, clay, we can have a root, you can have different fungal hyphae and all the things inside. That carbon which is inside micro aggregate within a big macro aggregate will be less liable to be lost under a climate change scenario than a carbon which is present outside the aggregate. So this is a very interesting research, and mainly I am doing this sort of research under different land use systems now at Delhi. So starting from our Almora days, as Professor Mukhopadhyay says, I worked considerable times, about 10 years at Almora, of which 3 years at UK. So we have different, management practices like nutrient management practices, zero tillage, irrigation management practices, diversified cropping, use of lantana. So this has different change in soil organic carbon and different change in yield, and in every case we found that there is positive yield change. So change in carbon positively significantly increases also the grain yield production, apart from zero tillage rain-fed scenario where the soybean equivalent yield was negative. This was mainly because of, under zero tillage condition, there was a weed matting cynodon dactylon, which was not actually controlled by the herbicide. That's why we standardized the tillage and management practices, and I am coming to that. So initially in this fertility experiment, what we see that about 20% of the added carbon was retained in soil under a long term, say about 30 years, 32 years of experiment under rain-fed scenario. But under irrigated scenario, after 12 years or so, we found about 25% of added carbon retained in soil. This percentage are more because this is temperate climate, subtemperate climate at Almora. We found different crop root to shoot ratio, because that is actually the roots and the biomass, they actually increase the carbon content in the soil. And we found that estimated carbon input in a soybean wheat system is much higher than the other system because of the leaf fall of soybean. But if you see the root shoot ratio, the millets are having more roots, like 0.32 and 0.33. About 1/3 of the portions of their vegetative growth is the roots. So as I said, that that tillage experiment is having less productivity despite increase in carbon in the 0 to 15 centimeter layer after 4 years of cropping, and also total soil nitrogen. And we have shown that legume system soybean P is having higher than soybean wheat. And the same experiment, and this is my first international paper in soil tillage research, we found as a physicist we worked on pore size distribution and unsaturated hydraulic conductivity calculation using Campbell's equation. This is the first time we did it, I think, in India, and I think second time in the world. So we found that our conservation tillage experiment is having not only having more saturated hydraulic conductivity, but also more unsaturated hydraulic conductivity. That is actually useful for production potential. But as I said, due to cynodon dactylon, the yield was not there. So we went for alternate tillage, seasonal tillage alteration, conventional tillage in Kharif, and zero tillage or no tillage in wheat. And this is one of the great experiments running for 6 years at Almora, and this is published in Soil Science Society of America journal. You can see that no tillage is having a maximum gain in carbon in aggregates, but which is comparable with the no till and conventional tillage plot. So you can see the labile carbon and as well as the recalcitrant carbon, there is no change because recalcitrant carbon takes more time. And we plotted macro aggregate versus soil organic carbon pools, and we found significant relationship between this pool 1 and pool 2. So other carbon sequestration options like carbon retention under grass beneath pine forest, hybrid Napier beneath the pine forest increase the surface total soil organic carbon after 3 years. We can have a manure placement instead of broadcasting the manures. We saw that manure placement increased the crop productivity by about 45%. You may be wondering why so much 45%, because the initial yield was very less. That is a very sandy loam and poorly fertile soil. Then we did land management in terrace farming. After 9 years, we found the productivity of 3 model sites increased from 2 to 4 megagram per hectare. Likewise, total soil organic carbon content determined after measuring stoniness. This is also one of the very in the hills the stones are there, so we have to take account for the stones before measuring the carbon content or nutrient content in hilly areas. And then we also did carbon retention under organic farming scenario, and we found significant amount, about 0.57 and 0.37 megagram carbon per hectare per year can be gained under organic farming system. Now coming to some of our experiment in the Indo-Gangetic plains, like here in Delhi at IARI. We have a conservation agriculture experiment. It is running for 9-10 years now. This result is after 5 years. After 3 years, we published results in European Journal of Agronomy. We found that whenever the conservation agriculture in forms of 3 zero tillage, in the 0 to 5 centimeter, there has significantly more carbon than your TPR CTW, that is farmers practice, and TPR ZTW, that is also farmers practice, because many farmers do transplanted rye and then zero till wheat. So even that gain was there in 5 to 15 centimeter, but not there in the 15 to 30 centimeter layer. Another experiment, this one is about 9 years old experiment. One of our students did this work in MSc, and we found that conventional tillage having significantly less carbon in the 0 to 5 centimeter under different residue management scenario. What we did, no residue, wheat residue, soybean residue only, and wheat plus soybean residue. So what we found that when both residues were there, the carbon content in the 0 to 5 centimeter is significantly more than only one single residue application. Similar results were found in 5 to 15 centimeter layer, and also 5 to 15 centimeter layer, zero tillage has significantly more carbon than other thing, conventional tillage. And we found some accumulation of carbon in the deep layer also. You can see the 0 to 15 centimeter, the carbon accumulation rate was higher in case of that residue management tillage. Under zero tillage, it is more than the conventional tillage. But in the 15 to 30 centimeter soil layer, although the interaction effect was not significant, but residue management has significant effect on increasing carbon in the deep layer. So that is also one of the strategy of carbon sequestration, if we increase carbon content in the deep soil layers. So apart from increasing recalcitrant carbon in the surface or deep soil layer. Now we found how much carbon actually were distributed within macro aggregates and micro aggregates, and also using 6 et al. Procedure, carbon stabilization within physical fractions, different physical fractions. As I said, in aggregates, we have micro aggregates. So we have carbon inside micro aggregates within macro aggregates. So first we measure within macro aggregates, zero tillage is significantly higher in both soil layers than conventional tillage, but the residue management had no effect. Although residue is having more than no residue, but among the residue treated plots there are not significant effect. We found also significant increase in micro aggregates under zero tillage treatment in both 5 to 15 centimeter layer, and then as I said, we found that portions, coarse particulate organic matter within macro aggregates, silt and clay within macro aggregates, micro aggregate within macro aggregate, light fraction in micro aggregate within macro aggregates, again particular organic matter fractions intra-aggregate particulate organic matter fractions in micro-aggregate within macro-aggregates. Like that, we found that the zero tillage scenario, all in the 0 to 5 centimeter layer, all fractions apart from silt and clay within macro aggregates were significantly more than the conventional tillage, and residue treatments, having apart from this fraction, all fractions are having significantly more than no residue treatment. As you know, carbon and nitrogen are closely related. We also did some work in nitrogen under permanent bed planting scenario in a maize wheat cropping system. When we have 100% nitrogen given in permanent narrow bed with residue and permanent broad bed with residue scenario, you can see significantly higher total nitrogen and also aggregate nitrogen, macro aggregate associated nitrogen and micro aggregate associated nitrogen in blade planting scenario. Here the beds were reshaped every year but not plowed. So this is an advancement over zero tillage, that permanent bed planting with residue management and 100% nitrogen. Another important thing is that when you use 75% nitrogen, there is no significant difference in total nitrogen and macro aggregate associated nitrogen or micro aggregate associated nitrogen. So we found global warming potential and greenhouse gas intensity, that is kg equivalent CO2 emission per kg of grain, and we found that significantly more GHG intensity in conventional tillage. That means our permanent broadbed system is more environmentally friendly, reducing the GHG intensity. So I just thought that I should share about the system productivity of this cotton wheat, pigeon pea wheat and maize wheat system, and these all are published in different international journals like Field Crop Research and Journal Agricultural Science Cambridge, and we found that zero till broadbed with residue having significantly more system productivity as well as net return than the farmers practice. So this one is also similar, that zero till with bed planting has more crop productivity. Conventional tillage with bed planting has more crop productivity than zero tillage with flat planting for cotton, but you can see for other crops it is similar. Now coming to fertilization experiment, long-term fertilization at Delhi. This is tropical scenario, so not much gain in carbon, but still about 80 to 90% gain in carbon from the control plots in the 0 to 15 centimeter layer, and we went up to 90 centimeter layer, and we found that about 50% of the sequestered carbon were in deep layer. Deep layer means 30 to 90 centimeter layer. So this is very interesting finding. Earlier people only used to study 0 to 15 or 15 to 30 centimeter layer, but not really up to 90 centimeter or 1 meter depth. So there we found in a novel approach what is the temperature sensitivity of that carbon mineralization, Q10. Using Van 't Hoff's equation, we found that that NPK plus FYM is having less Q10 than some of your treatment like NP. That means under climate change scenario, under temperature scenario, this carbon is less liable to be lost because carbon is protected inside micro aggregates within macro aggregates. You can see, but the micro aggregate carbon are more temperature sensitive, but not the macro aggregate carbon, because my micro aggregate carbon it is very well which are exposed outside. Those carbon are micro aggregate carbon. So as I said, that 6 et al. Scheme, after 60 years of fertilization, very interestingly we found that only FYM treatment is having less micro aggregates inside macro aggregate than your some of the NPK treatment or NPK plus lime treatment. Of course, with NPK plus phosphorus, potassium plus lime treatment. So this is very in a clay loam soil. This experiment from Ranchi, one of our MSc student did this work, and this is very interesting that if NPK is having more micro aggregate inside macro aggregate than only FYM treatment. So manure carbon not really going inside the physical fraction of so more carbon here liable to be lost than here. As you know, I did my postdoctorate work at University of Queensland, where we studied different land use systems like undisturbed soil, pasture, plantation, and crop, and all were having a different history, like 67 years of cropping, and then when they converted to pastures, the 34 years ago they did it, and then from pasture to plantation 16 years ago they did it. So this is the detail of the land use history. And interestingly, we found that undisturbed soil is having more large macro aggregates, but not small macro aggregates. Small macro aggregates were more in pasture soils, as well as cropped soils. So this says that here I can say that this soil is having very large amount of macro aggregate because of more carbon content. That's why this soil is having a higher aggregate stability. We went for pore size distribution and macro aggregate pore structure analysis by computed microtomography. Where we found that a large macro aggregate from the undisturbed soil is having more significantly higher macro pore than other cropping systems, than other land use systems, and also having more porosity. But when you see the crop soils, they are having more micropores. So more tillage, causes breakdown of the macropores and causes more micropores inside the aggregates. This is key word. This is inside the aggregates. So in those land use systems, we found the total soil organic carbon stock and total nitrogen stock. As you can see, cropping to pasture conversion improved soil organic carbon by 3.5 megagram per hectare in 34 years, and pasture to plantation conversion increased soil organic carbon by 7.7 tons per hectare in 16 years. So the reduction of soil organic carbon and total soil nitrogen stocks under cropping were related to lower soil organic carbon and total nitrogen concentration in aggregates and higher activities of carbon degrading enzymes like phenol oxidase and alpha glucosidase per unit sand-free carbon. So we went for another site, that is Lamington, where carbon content is much more. There the forest soil is having more carbon than pasture soil, and we found the temperature sensitivity of carbon decomposition in aggregates. This is published in Soil Research. The Q10 value of you can see the small macro aggregates is more in forest soil than the pasture soil. So this is very interesting. Also, the similar trend was not observed for also observed for activation energy. At Australia, again in a Watt as well, there is a 49 years of experiment where conventional tillage and no nitrogen, and conventional tillage with 90 kg of nitrogen per hectare per year and zero tillage with 90 kg per hectare per year. You can see zero tillage with 90 kg nitrogen per hectare increase significantly soil organic carbon. Soil organic carbon in large macro aggregates, soil organic carbon in small macro aggregates significantly, but not in micro aggregates. Now coming some of the work under climate change scenario. What happens under elevated CO2 scenario? Say after 7 or 8 years of multiple cropping in the 0 to 45 centimeter soil layer, we found that despite there was significant increase in crop productivity under elevated CO2, but soil organic carbon change was not significant. You can see all soil layers having similar carbon concentration to the ambient CO2. We found the reason for that. We found the soils under elevated CO2 increased very labile carbon pool, but decreased both labile and less labile carbon pools. This is the Chan et al. Procedure, you know, by which anybody speaking something?
No, actually, I think there is some interference from outside. We are not finding the means who is.
Okay. I'll continue. Okay. So soils under elevated CO2 had 45% higher large macro aggregates we found, but had 15% fewer micro aggregates than the soils under ambient CO2 in the topsoil. So this is very important, that there was a change in aggregate structure under elevated CO2 scenario. Micro aggregate, they are not, because of the more labile carbon input, more biomass input, more labile carbon input, there were more large macro aggregate formation. But there is actually micro aggregate, fewer micro aggregates. I will be coming why fewer micro aggregates. Because soil under elevated CO2 had 25% less micro aggregate associated carbon than soils under ambient CO2. The greater amounts of labile carbon in macro aggregates may be subject to enzymatic decomposition because of the nature of the carbon, whereas the enzyme activity of micro aggregates may be high, possibly due to immobilization of extracellular enzymes. So I found several research papers which actually supporting our idea. We can see that micro aggregate within macro aggregate is a potentially robust indicator for management induced soil organic carbon that is a biological origin, and therefore is useful for interpreting impacts of soil biota, and a good candidate for being incorporated into models as a measurable fraction. Now, that why that micro aggregate carbon was less under elevated CO2 scenario, because of AM fungi, and that paper published in Science in 2012, that AM fungi deposits slow sliking organic compounds like glomalin and chitin and protect organic carbon from microbial attack by promoting aggregation, that we know. However, AM fungi growth can result in enhanced decomposition of complex organic carbon. So soils from elevated CO2 had higher phenoxidase activity than soils under ambient CO2. So that is one of the indicators that AM fungi actually eating some of the carbon present in there. So likewise, our literature said that soil microflora and the associated soil enzymes will determine the fate of carbon residing in aggregates and the loss of stabilization of particular soil carbon compounds. That's why nowadays we are measuring, carbon cycling enzymes within aggregates, and we are finding a procedure and we are doing that work. Now another 5 years experiment under open scenario, that elevated carbon dioxide and elevated ozone condition, you can see elevated ozone decreased labile carbon and total soil organic carbon, but not the recalcitrant carbon pool. Soils under elevated carbon dioxide had about 17% higher large macro aggregates than soils under ambient CO2. However, elevated ozone had decreased large macro aggregates and increased sill plus clay hydro fraction. So that means more aggregate breakdown under elevated ozone scenario because of less productivity. And also we found that soils under elevated CO2 had significantly more carbon within macro aggregates, but less micro aggregate associated carbon than soils under elevated ozone. So confirming the earlier results. So coming into, I never worked vigorously on agroforestry system, but agroforestry system also have important and have nice carbon sequestration potential. And you can see eucalyptus and agri-silvi system that are having about highest 7.5 tons of carbon per hectare per year potential. But according to Lal 2019, if you see in the global scenario and the tropical areas, that conservation tillage can have about 0.2 to 0.5 tons per hectare per year carbon sequestration, and conservation agriculture 0.3 to 0.8 tons per hectare per year, which is much more than your nutrient management. But highest, of course, is the afforestation and agroforestry system. So likewise, a good study in bioresource technology by Professor Manna from Bhopal. They found carbon accumulation rate under coconut based system, different kg per hectare per year, and they found coconuts plus sapota is having higher carbon accumulation rate. So in Almora, what we did actually, we did some work on carbon sequestration and emission reduction scenario. CFL bulbs have been distributed, solar lanterns have been introduced, hybrid napier as a grass have been planted in different slopes. I already told that hybrid napier is having soils under hybrid napier having more carbon than soils having no hybrid napier. Wheat and finger millet have been sown under zero tillage in about 5 hectare land area in Almora and nearby villages. 10 solar cookers have been introduced and 12 vermicompost structures have been developed. So I was a part of the as a co-PI these works. We have also about grid area of 2,200 hectare geographic area in 13 villages, where we planted about 30,000 fruit saplings, 9,000 other fruit saplings like mango, guava, and 8,000 tree saplings like oak, alder, bhimal, and mulberry. And also we analyzed the initial carbon content of 500 soil samples. Then I left Almora, and I am in touch with the scientists that they will be analyzing, after 6-7 years, 8-9, not 7 years, after 8-9 years, what is the gain in carbon or what is the change in carbon. In Delhi, as per the wish of the director, I was the PI for initial 3 years for developing a 1 hectare model. So as you know, 65% farmers are having below 1 hectare land area, and nearly 40% of them are vulnerable, marginalized, and food insecure. That's why IRI has developed a sustainable agriculture model for peri-urban and rural areas, for 1 hectare rain-fed as well as irrigated scenario. And if you visit IRI, we can have a look at those things. So what are the research issues actually? I just outlined 3-4 research issues, like in conservation tillage or conservation agriculture scenario, which tillage management practice is suitable under a particular soil type and cropping system, and how duration of conservation agriculture practice would affect carbon sequestration. So that we are working, and people should work. We should have a carbon balance under location specific conservation agriculture, harvest residue management on tree growth in a model farm, and year round vegetable production system, flower, grain, vegetable system, because we work less in vegetable or flower or these systems. We should extend our carbon sequestration study on those areas, like mango tree plantation. So like at IARI, you have a mango forest, you have a cover crops and all those things. If the plots under conservation agriculture system would have higher soil organic carbon content in the labile pools or in deeper soil layers and improved aggregation than conventionally tilled plots is not really known. So after 10 years or so, we are studying deeper layers how much carbon is accumulated, is really accumulated in deeper layers under conservation agriculture, because we expect that, because there is about 20% increase in system productivity. So every year it is accumulating 20%. So we expect some root biomass increase in the deeper layer that could contribute to the carbon sequestration. Each soil organic carbon occluded within micro aggregates responsible for the greater soil organic carbon sequestration, and is there any role of glomalin in the plots under conservation agriculture and aggregate stability? So I have published 1 or 2 papers. Due to paucity of time, I did not show any research work on glomalin, But we found that glomalin, yes, when conservation agriculture is there, there are significant increase in glomalin, and we also found glomalin in macro aggregates and micro aggregates, and that has a significant role in increasing, aggregate stability. What is the relationship between carbon management index and soil loss rates in your hilly arable lands? We know carbon management index, but if we improve the carbon management index, does it really decrease the soil loss? That is very important. So before coming to end, this is Serbian proverb that soil which is sustainable only if loved, and be humble, for you are made of earth, be noble, for you are made of stars. Thank you all. Thank you for your kind attention.
Thank you very much, sir. It was really enriched us, because lots of work on conservation agriculture is being done by the Department of Soil Science, Uttar Krishi Vishwavidyalaya, and we are having a long-term experiment since 2006 here. So it was really it really showed us a way what should be our future research. So now I ask the participants one by one, you kindly ask if any queries you want to ask from Dr. Bhattacharya. Students, you are requested to interact. If anybody wants to type it, you can type, and you can, so that we can pass it on to our. Yes, I am finding somebody trying to connect, but he's not able to connect it. Okay. Okay, I think Dr. Shobhik Dev, one of our faculty members, you have some question. You can ask Shobhik.
Sir, myself, Dr. Shobhik Dev. Am I audible, sir?
Yes, yes.
Okay, so I also work on soil carbon and aggregate analysis a lot about this. So I'm having a query. So the microtomography you have explained us. So is it a good technology to understand the pore geometry as well as the EPS? I mean, exopolysaccharide saturation in the pore geometry. I mean, yes.
Yeah, this will not give you exopolysaccharide saturation, but this will give you the pore structure and pore geometry inside aggregates. Yes.
Is it also for macro aggregates as well as micro aggregates?
Yes, it can be done for both macro and micro aggregates. But for micro aggregates, the work is very tedious because micro aggregate size is so small. You have to, put it in the tomography machine very carefully, and also, have the good resolution, good adjustment.
Okay, sir.
Professor Dibyendu Mukhopadhyay, please.
Dr. Bhattacharya, thank you very much for your very nice presentation and the span of work you have done initially and later on, where you are in India and abroad subsequently, over the carbon sequestration and conservation agriculture. The thing is that as we are in the North Bengal scenario, where there is different kind of biodiversity, there is established forest ecosystem, there is tea garden belts, and there is agricultural land, and of course, to some extent, fallow land situation. But particularly in the hilly area, there is slopy land situation, and huge rainfall, nearing 3,000 millimeter average rainfall is there. So there is chances of soil erosion, the top fertile soil. Still, there is existing forest land situation. There are different kind of stand of forest with different diversity. And soil carbon, for instance, is over 1%, nearing 1.5 or like that in that region particularly. So at this situation, the buildup of carbon is very slow, and the climate is one of the important factors. So if we consider to have some work on this carbon sequestration or developing the carbon sequestration potential, So particular in that hilly regions where the carbon content is quite higher compared to the plain regions. So what kind of research work should be taken on the long-term basis? Because as Professor Sinha has already told you that long-term research is going on since 2006 onwards on conservation agriculture and carbon sequestration in the plain land situation. So I just want to hear from you in that direction. So what our students or faculties can thrive into for carbon sequestration potential.
Thank you very much. Yeah, that's a very good question. Under the hilly areas, when you have a slopy lands, first of all, I think we should go for buffer strips to check the erosion. Once you check the erosion and the eroded carbon, that will slowly aggravate the carbon content of the soil. Apart from that, one should do for conservation tillage sort of things, or zero tillage, because it will not break the aggregates. And then, with appropriate weed management practices, if you can continue for say 5 years or so, it will increase the carbon content, I suppose. So it's a combination of your manure application, your zero tillage, your buffer strips, mulching. These combinations will work under hilly areas.
Thank you very much.
Sir,
Yeah.
Sir, I want to know a silly question. Sir, how to measure soil erosion rate in hilly areas and the nutrient loss from soil erosion rate? How to measure, sir?
Yeah, there are different techniques, but I found the manual techniques is the best one. You have runoff plots. Have you come across the runoff plots?
No, sir.
Where you have border the runoff, certain area, and you have a big pit in the down, and you have a drum or something like that to collect the sediment. So every week or depending upon the rainfall intensity, you can visit and collect the soil and water lost in the drum, and whatever soil, then you dry it and then you analyze how much is the nutrient loss from the soil and how much is the soil loss rate. Of course, there are different models to find soil loss rates. You can Google it and you can find it.
Okay, sir. Thank you.
Sir, I'm Shobhik, sir. One more question from my end, sir. We found it difficult to identify or separate micro aggregates. We all have, both wet sieving machine and dry sieve checker. But the issue is, we also tried to identify the different characteristics of micro aggregates specifically on XRD, and also, we tried to do it in ACM. But the issue is, it is very hard to find the actual micro aggregate. Sometimes it is broken macro aggregate. Sometimes it is plotted micro aggregate. So, sir, can you please suggest how to identify micro aggregate?
So you isolate the micro aggregate first. You isolate by the following 6 et al. Procedure.
Okay.
What are the micro aggregates inside the soil?
Sir.
So you have to take more soil samples. Okay. And then you isolate the micro aggregates, which will pass through 0.25 millimeter sieve, but it will be more than 0.053 millimeter sieve. So that portion is your micro aggregate, and there is no question that portion will come macro aggregates.
So sir, we do it, but the issue is sometimes we feel it that it may be broken macro aggregate also, or plotted micro aggregate maybe also. So
no, if your macro aggregates are broken, because that is a natural phenomena, macro aggregates broken to micro aggregates, and then micro aggregates again accumulate to form macro aggregates. So if it is broken, then we consider it is a micro aggregate, not a macro aggregate anymore.
Okay. Okay.
And that is a natural phenomena.
Okay.
Anybody else who wants to ask any question, because he's a very enriched resource person, you can ask anything on conservation agriculture related issues. Sir, I have one simple question, that in short term conservation agriculture practices, which of the soil means parameters, or rather I will say indicators, we can pursue so that in a short term basis we can get that this thing is working or not?
Yeah, in short term basis, you should see if there is increase in large macro aggregates as well as labile carbon. So if your large macro aggregates increase as well as labile carbon increase, then you can see your conservation agriculture is working, because slowly that will over the years slowly turn into from labile to recalcitrant carbon. But that may take time, but more labile carbon is good indicator.
Okay, sir. Thank you, sir. Anybody else? Okay, I don't find anybody. So I will request Dr. Dev to summarize your this seminar topic. Please, Dr. Dev.
I, Shovik Dev, would like to thank our Vice Chancellor, sir, for facilitating this webinar, the departmental webinar for us, all the dean and directors and coordinator, convener and joint conveners for this purpose. I would give my hearty thanks to Dr. Ranjan Bhattacharya, who gave his time for us, his valuable time. And in a very nutshell, I would like to summarize his, whole lecture. So actually, he first described the soil conservation and carbon sequestration and their requirement for sustainable agriculture. He said us about the severity of erosion in Indian context. We lost approximately 6,000 million ton of soil per year from Indian surface. And then he shared his PhD works, which was on geotextile mat and their applications all over the world, and estimation of splash erosion and soil quality of the eroded plots. And he also described us the importance of cover crops and intercropping mulching. And then he came about the topic of the carbon. And because soil is the largest terrestrial reservoir of carbon, which stores 2 to 3 times of the carbon than the atmosphere, he described us as, about the carbon sequestration procedure and importance of soil microaggregate, macroaggregate, macro and microaggregate occluded carbons, his present researches, and then carbon retention under different management practices, under different cropping systems of the Himalaya. He then shifted about his research about the tillage and conservation agriculture and their role on soil aggregate and soil carbon sequestration, also on soil nitrogen dynamics. And he then described his work on the deep soil carbon sequestration, because we know deep soil carbon is a more recalcitrant one, more stable carbon. He also shared his works on long-term fertilization experiments and their impact on the soil organic carbon, soil aggregates, and aggregate occluded carbon. He shared the pore structure geometry within the macro and micro aggregates and land use land cover changes and their role on and their impact on soil carbon dynamics. And then a very new topic, that is soil organic carbon pools under elevated carbon dioxide, macro aggregate, and within micro aggregates, their relationship with the arbuscular mycorrhizae and their interactions under elevated and normal carbon dioxide concentration. And last of all, he shared about the sustainable agriculture model, which it is running at this moment under his under him at IRI. And also in a brief time, he described about the research issues like carbon balance under location specific conservation agriculture, and harvesting the residues, and carbon management index, and its interaction with the soil losses, etc. So thank you, sir. Thank you very much for this very precise and very, very elaborative, but precise, but elaborative and very informative lecture. We who work on carbon, we got a lot from you. Thank you very much, sir, for your time and for your lecture. So I'm handing over this mic to Professor Sinha.
Thank you. Thank you.
Thank you, sir. Thank you, Souvik, for summarizing this webinar. Thank you, sir. We were very grateful to you that you gave such a lecture. So we will be moving to our next topic at 12:30. So all the participants are requested to stay online. And I, on behalf of Uttar Pradesh Krishi Vishwavidyalaya, want to welcome Dr. Kamlakar. He's from Pandit Jayashankar Telangana State University. Sir, so please, I heard a lot of things from Ravinder and Rakesh. So I welcome you in this webinar, sir. Thank you. So we'll move on to our next. Just give us time, because our speaker, I have talked to him. He will be joining us just 5 minutes before the next session, which is starting from 12:30.
Okay, thank you very much. It's my pleasure and honor. Thanks for inviting me for giving the lecture.
Thank you, sir. Okay, one announcement for the participants that we'll be sending a feedback form after this series of our lectures in this webinar. Not for today, means entire series, and we'll be giving you a certificate at the end of this webinar series. Okay, so if somebody who has joined earlier and not joined today, so you kindly mail me what the mail of you can collect the mail from different students if somebody who is not got my mail directly, and I will send the certificate to the participants. Okay, thank you. We will be joining very shortly. Stay with us.
Hello, good afternoon. Hello, good afternoon, Dr. Dibbendu sir.
হ্যালো, প্রিয়ব্রত?
Yes sir.
কেমন আছো? ভালো?
হ্যাঁ ভালো আছি। অ্যাকচুয়ালি মর্নিং এ মিস করলাম, ইন্টারনেট কানেকশনটা একটু প্রবলেম হচ্ছিল, তো রঞ্জনদার লেকচারটা আমি অ্যাটেন্ড করতে পারলাম না।
হ্যাঁ, আমি এই জন্য লিঙ্কটা পাঠিয়ে দিই, আওয়াজ তো পাঠিয়েছিল, আমি আবার রিসেন্ড করে দিয়েছিলাম যদি অ্যাটেন্ড করা যায় আর কি, খুব ভালো হয়। তো এরপরে আমাদের আছে ডক্টর ঘাটালা আছেন, ডক্টর এসপি
মহেশজি আছে তো?
আজকে তিনটে আছে, মিলে
আচ্ছা
একটা তো
আচ্ছা
হয়ে গেল। আবার পরে
ওকে।
শিডিউলটা দেওয়া হয়েছে, শিডিউলটা আমাদের
হ্যাঁ শিডিউলটা তোমার মেল থেকে আমি পেয়েছিলাম।
আচ্ছা আচ্ছা, ওইটাতে একটু
না ওটা আভাসজি পাঠিয়েছিল মনে হয়, আভাসজি পাঠিয়েছিল।
হ্যাঁ হ্যাঁ হ্যাঁ, আবাস কি বলে দেওয়া হয়েছিল, অ্যাকচুয়ালি মেন এটা ইয়ে করছেন। তো যা অনেকদিন বাদে দেখা হলো, ভালো লাগছে।
ওকে।
এমনি ভালো তো?
হ্যাঁ হ্যাঁ, তোমাকে অনেকদিন পরে দেখলাম। এটা কোথায় বসে আছে? তোমাদের এক্সাম হল নাকি?
না, এটা আমাদের স্মার্ট ক্লাসরুম, অ্যাকচুয়ালি স্মার্ট ক্লাসরুম। তো আমাদের এমনি ওয়েবিনার সিরিজ বা অন্যান্য, এখন তো তোমার এই প্যান্ডেমিক সিচুয়েশনে তো ফিজিক্যাল ক্লাস নেওয়া সম্ভব না, ওই প্ল্যাটফর্ম গুলো আমরা ইউজ করছি আর কি।
হ্যাঁ।
আর স্পেসিফিক্যালি স্টুডেন্টদের রাখা হয়েছে এমএসসি পিএইচডি যারা আউটগোয়িং, যে কোর্স গুলোকে হাইলাইট করে সয়েলে যে ডিফারেন্ট ব্রাঞ্চেস গুলোকে হাইলাইট করে করা হচ্ছে। হ্যাঁ, যাই হোক, তোমার তো আছে, লেকচার আছে বোধহয় পরে, কবে?
আমার তো আছে 27 নভেম্বর।
27 তারিখে, হ্যাঁ 27 তারিখ। ঠিক আছে, তুমি থাকো, আমাদের ঘাটালার সাথে বোধহয় জয়েন করছো।
হ্যাঁ।
Good afternoon, everybody.
Okay.
Thank you, Dr. Priyobroto Satra sir. I will now request, because Dr. Mahesh Ghatala has joined the webinar. So, Maheshji, welcome. Good afternoon. Am I audible?
Good afternoon, sir. Good afternoon, Abbasji. Yes, it's clearly audible. I am audible to everybody? Clearly?
Yes, you are audible. So, just few seconds. We'll see.
No problem. When you have, ready and comfortable, please let me know. I'm here.
No, we are ready. We'll be just waiting for few seconds.
It's okay. It's okay.
Okay, Maheshji, we will start. Good afternoon, everybody. In the today's second topic will be delivered by our very honorable Mahesh Kumar Ghatala, Dr. Mahesh Kumar Ghatala. So we have been working since 2012-13 onwards on conservation agriculture related program. So I will just introduce to the audience. Dr. Mahesh Ghatala obtained his BSc MSc from Rajasthan Agriculture University and his PhD in soil science from Maharana Pratap University of Agriculture and Technology, Udaipur. Currently, he has been working since 2011 with CIMIT under Sustainable Intensification Program as a senior agronomist. Presently, he is based in Bangladesh, and Dr. Ghatala made strong contribution to strategic research, development, and deployment of conservation agriculture-based sustainable intensification, crop production and farming system, small-scale mechanization innovations for youth and women, micro-entrepreneurship, and capacity building among the farmers and the partners. So he is also very closely related with UVKB because he was associated, he's still associated with us in a project which was sponsored by ACIR through CIMIT. So he has developed lots of what I will say cropping system model for our area, which were conservation based, and so he is basically based in South Asia. So before joining CIMIT, Maheshji worked with ED as a senior scientist and initiated CA-based research platform in Northwest IGP, working in collaboration with RWC, CIMIT, and similar partners in India. Dr. Ghatala has extensive experience working in South and West Asia and has a strong partnership network with private sectors, NGOs, CG organizations, donors, and key government research development and policy leaders in their respective field of conservation agriculture. Maheshji has worked hard and he has coordinated several mega projects throughout this entire Indo-Gangetic plain. Dr. Ghatala works to reduce poverty in the EGP by improving the productivity, profitability, and sustainability of smallholder agriculture. And he has published 150 referred international and national journals, book chapters, bulletins, reviews, and synopsis proceedings. So I will now request Dr. Ghatala to deliver his topic, and Sir, floor is for you.
Thank you very much, Dr. Abbas, and this is my great pleasure, and I heartily thankful to Department of Soil Science of UBKB and the head of department to invite me and giving me this opportunity. Hope this is audible, and my screen is I'm sharing the screen. Hope it's visible to everybody. Okay, good. So today's my talk, we will talk on resource conservation towards agriculture production potential. This is the theme. And I will talk about conservation agriculture based sustainable intensification in Eastern Gangetic Plain and as well as in India and as a whole globally. What is the status of conservation agriculture? Yes, you can reach me for any questions. You can see my email. That's called m.gatala@cgiar.org. And here I am working in CIMIT from 2011, as rightly said by Dr. Abbas. I worked very long and strongly with close collaboration with UBKB and especially West Bengal team on to promoting on scaling the conservation agriculture in West Bengal and Eastern EGP of India. So I will go through, but before that, I will go through that where I am working and to whom I am working. So I am working for International Maize and Wheat Improvement Center, which is based in headquartered in Mexico. You all heard about that. And our mission is that wheat and maize science for improved livelihoods. That's our main focus for food security and to remove the hunger. We are the institute of part of the consultative group of International Agriculture Research Institute. Generally, we called CGIAR institutes. Our presence in Asia, Africa, Latin America, and South America. And then mainly we focused on impact on smallholders through partnership. Definitely our close collaboration and in contact with our headquarters in Mexico. You should also know that what is CIMIT and what is the contribution of Indian scientists in CIMIT. You know that cement is grown in 1940 through one of the, semi-dwarf wheat shuttle breeding. And there was even a research platform in Mexico, and then later is converted as a cement. And Norman Borlaug is awarded the Nobel Peace of Prize for Green Revolution. Everybody knows about that probably. And then we can see Indian scientists, Dr. Bashal, Dr. Pandey, and Dr. Rajaram, Sanjay Rajaram, and these are the pioneers. That's they all wrote World Food Prize. Those are Indian origin scientists, and they are working still. Still, there are a number of significant scientists working with CIMMYT from India, and they have a great contribution in breeding, in management, in conservation agriculture, in mechanizations, in so and so. So these are the contribution of CIMMYT. This is my background, what I will talk today, so I will not go. So I am coming now. That's how we are dealing the challenges, a storm of challenges, I would say, and that's needs business unusual, because we cannot deal these all challenges with business as usual. That's as we are doing. And you know that high employment is coming, unrest is, and migration is there. That's creates a lot of conflicts and fragility in the communities, and which is every day is coming, and we can see in different parts of the world that we will see the unrest and conflicts and then boundaries and food securities and so on. So if you look at that, food and nutrition insecurity, and that leads, if there is no enough food and nutritional food is not available, we will heavily face the malnutrition, which is, if you know that in India itself we have millions of children suffering from malnutrition, and then high population, which leads to demographic changes, gender inequality, which we can see, and more towards urbanization, and we can see hot spots for fightings, and agitations and protests and all. And that's coming due to, high population pressure. And if you look at particularly in Eastern EGP, including, Eastern India, Bangladesh, and Trai of Nepal, this part of the world is highly dense in the world. And then it's more than, 1,000 persons living in 1 square kilometer areas. So we can understand that, population pressure in this region. Land degradation is coming due to desertifications, and, like we were doing conventional and more clays, and then, imbalance of nutrients, and then, faulty management practices, so on. So that leads to soil, land degradation and desertification. And used to grow many kinds of crops, diversified crops, like so many crops, and then they are growing, and that was, maintaining the agrobiodiversity. But look at that, now we are moving to monocropping system. So we moving either rice wheat, rice maize, or so on. So if you look at northwestern India, we more focus on only rice wheat, which is not the right, and it's not the zone for rice wheat, because it's especially for rice. So that's, we need to look again and go back. That's how we can diversify our system to improve our agrobiodiversity. Water scarcity, especially I belong to Rajasthan, I understand what is the pressure of water scarcity. Earlier, I remember in my childhood we have a sufficient water, but there is no water now. Water is, we exploited whole water. There is no aquifers available. If you want to go for even drinking water, we have to go for like more than 3,000 to 4,000 feet, to wells, and then we will get very little amount of water for drinking. So if we not use, judiciously in this region also water as efficiently or judiciously, maybe we'll face same problem as we are facing in other parts of the India. So we must be careful about water, using and pumping. And definitely we are, challenging, and facing the major problem of climate change with the increasing temperature and reducing precipitations and aberrating rainfall pattern as well as. So there are many challenges we are facing, and how to deal them. It's not easy. So we have to think innovatively and out of the box how to deal these kind of problems. If you look at that, soil health is depends on three properties. That's physical, biological, and chemical. And these properties is mainly governed by the management, how we are using our fields, how we are managing them, what kind of cropping systems we are taking them, which kind of fertilizers we are adding, which kind of pesticide and herbicides we are adding. So that depends, and that leads to these all three physical, chemical and biological properties. What do you mean by physical properties? Physical properties that's support to our plants physically for stand and grow. That's helps to soil water retention and movement of water within the soil through diffusion, mass flow, and there are many processes. I don't want to go in details. And it's also controls soil erosion, because if we improve our physical, soil physical properties is improved, which we have better soil structure, better aggregation, which is less available for soil erosion, either or both wind erosion as well as water erosion. And also soil physical properties governs and leads to soil hardness. That's if good soils, maybe less hardness. If bad soils, bad structure, will get harder soil, which is more difficult to grow plant and root development.
Mahesh, am I audible? Mahesh, ওনারটাই চলে গেছে। Somaresh, can you hear me? Somaresh, Huda, you can hear me?
Yes, sir. আওয়াজটা শোনা যাচ্ছে, ওনার চলে গেছে।
ওকে 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 ওকে।
Yes, sir, শোনা যাচ্ছে।
ওনার দিকে প্রবলেম হচ্ছে। ওকে, I will contact him.
Yes, sir.
Yes, sir.
ফোন করো। ওনার মাইকটা অনমিউট হয়ে গেছে। ওনার মাইকটা অনমিউট আছে।
হ্যাঁ, আমি ফোন করছি ওনাকে।
Dr. Mahesh, please unmute yourself. We are not audible to you. Dr. Mahesh, your microphone is unmuted. Muted. Please unmute it. Hello, Dr. Mahesh ji.
আমার মনে হয় ডক্টর সাতরা উনি হ্যাং হয়ে গেছেন কোনো কারণে।
Okay.
আমি ওনাকে রিং করছি, রিংও হচ্ছে না।
কেননা ওখানে দেখা যাচ্ছে ওর মাইক্রোফোনটা মিউট হয়ে আছে আর কোনো কারণে হ্যাং হয়েছে।
হ্যাঁ হ্যাঁ,
নেটওয়ার্ক প্রবলেম থেকে হতে পারে স্যার, এটা নেটওয়ার্ক প্রবলেম হয়েছে।
আওয়াজ দাও, মেসেজ করে দাও, মেসেজ, যদি ফোন না ধরে।
ওকে 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 ওকে, yeah. It's all right.
Hello.
Hello, Mahesh, we can hear you.
I'm back now, sir. It's audible.
Yeah.
It's audible.
Okay.
Maybe,
so can you somebody tell me where I disconnected so I can start from there?
Yeah, you are showing that soil quality, physical, chemical, and biological slide. So, Mahesh, one thing before going to your slide, I forgot to mention that our Dean Faculty Agriculture, Professor Dibyendu Mukhopadhyay, and who's also the head of the department, is here, and also Dr. Priyobroto Satra, he's from ICR, so he's also here. Kajri, so he's also here. So, sir, I forgot to mention. So, I again ask you to move on with your lecture.
Thank you very much, Abaji, for letting me know. And I thankful to Dr. Bandyopadhyay for giving me this opportunity and present here. Hello.
Yes, Mahesh, you are audible. You are audible, and we can see the slide. This was the slide you were showing.
Okay. So I am coming again that maybe I missed that how soil health is governed by three physical soil properties: physical, chemical, and biological. And that's these properties is mainly depend on how we are managing our fields. This depends on which cropping systems, how cropping system we are, how we are adding fertilizers and organic matters to the soil, and it's also like depend on that what kind of farm typologies and soil it's available, and that's governed by all these physical properties, and that's mainly governed by the management, especially that's how we are managing our soil in terms of cropping system, in terms of fertilization, in terms of pesticide, in terms of organic matter, and then in terms of recycling and continuation of cropping system and puddling and all. So if we go through physical properties, that physical properties is mainly support to our plant for physical support for plants grow, as well as it's also soil water retention and movement. That's we talk about like diffusion, mass flow, and so on. So I don't want to go in details. And soil erosion, because if our soil physical properties is good, then it's less available for soil erosion for both wind as well as water erosion. And that depends how our soil, and aggregations is improved through soil physical properties. And also soil hardness, that depends. If our soil is good organic matter is there, then good soil structure is there, we will find less hardness of soil, as well as if destroyed or deteriorated soil structure there, we will find more hardness in soil. That can be create a problem for seed emergence and plant root development and all. We will come on chemical properties, ECPH, and like cation exchange capacity and so on. So that governs nutrient retention and release pattern, that mineralization and so on. So of nitrogen and organic matter decomposition. So soil reaction is governed, soil release and available of all soil essential plant nutrients and all. And then it's also stored energy in form of carbon, and that's available for mineralization and that create energy through in the process of both mineralization and nitrification and so on. So biological properties depends how our fields are in terms of weed and pest separations. If good soil health, then soil will suppress weed and pest by good plant health. And it's also microbial biomass, that depends on how we are adding soil organic matter to the soil. It's also governs and mineralization, that depends on seam ratios and all, and definitely organic matter decomposition. So these three properties mainly depend on how we are managing our soil. And now I am coming to Eastern migrating zones, how this is difficult as compared to other parts of the world, as well as that. If you look at that, our most of farmers are, lying in 70 to 90% as small and marginal farmers. So we cannot, and that's small and marginal farmers means less than 1 acre. It's less than, and that land also is further fragmented. So its challenges are further, difficult to us. That's in terms of mechanizations and then technology use and so on. So it's not easy. And cropping intensity is good, but productivity is very low, because again, due to so many factors, especially soil management and land fragmentations and available resources like water and all informations and so on. So we are mainly, either growing rice or rice-based systems. And now we are coming, that's new system is coming as a rice-based system in these regions. And that is more profitable. I will come later on this. Before going on conservation agriculture, earlier, if you remember when we started conservation agriculture or zero tillage in India, conservation agriculture means it was only zero tillage. There was no other considerations. And that was the mistake that we done. Conservation agriculture doesn't mean that we will do only no-till and we'll say conservation agriculture. No, conservation agriculture, it depends on many factors, and we have to deal as a whole system. And in that way, if we define conservation agriculture based sustainable intensification in this region, then conservation agriculture based management practices, it means reduction in tillage, doesn't mean that we will go for only no tillage. Depending on cropping systems and all, how we can reduce the kind of ill effects of tillage, a drastically reduction of soil disturbance. That should be our motto, rather than we'll say, oh, completely no-till and it's depending on cropping system. If we say potato, and people will ask immediately that how is possible potato in no-till system? Yes, we agree. Yes, planting of potato is possible in no-till system, but for harvesting, we need to be disturbed at some level of soil, taking out and harvesting of potato. But our goal should be reduction of number of tillage operations and disturbance of soil, rather than we will stick with 3 principles and say, oh no, you cannot disturb soil. So it depends how we apply principles as per the site, as per the soil, as per the local conditions. That should be our target. If we reduce the number of tillage and soil disturbance, doesn't mean that we should not target efficient use of external inputs and natural resources like fertilizer, herbicide, pesticide, so on so. And as well as also natural resources like soil and water especially. So we need to be efficiently use of those, optimize our external inputs, and as well as efficient use of our natural resources, especially water and soil. And if our options of what we are talking about, conservation agriculture, sustainable intensification, are not economical and profitable and viable to the farmers, we should forget to promote conservation agriculture. Our option must be viable or economical to farmer. In that way, only they will adopt. Otherwise, they will not adopt. They will say that, oh, your soil will improve after 10 years. Your environment will improve after 10 years. Farmer don't care about that. Farmer immediately care about economic and profitability and yield. So those should be, keep in mind while we promoting our conservation agriculture. Definitely our system, whatever we are talking, that should be fit within the farmer system perspective in terms of livestock, in terms of cropping system, in terms of other farm typologies and so on. So that should be fit in that farmer's system. That then farmer will adopt the conservation agriculture practices. Otherwise, we'll push that to the farmer that, oh, you should adopt, you will get this benefit. Farmer will not do, because farmer is more intelligent than us and they will do their own decisions. So that's the principle that we need to be followed to promote conservation agriculture. And these, if you follow these practices and principles, and that will take our system is more resilient as a whole system. We'll save more water and energy for future. Will give better clean environment. Nowadays, we hear that, and this problem is coming like burning in eastern part of India as well. Earlier it was not there, but nowadays it's very hot, topic and discussion in Delhi and Northwest India about the residue burning. And you look, that's kind of a smoke because I came 3 days back from Delhi, and it was a smoke, complete Delhi, and you cannot breathe properly. So we need to think about future, that how we can do, and that conservation agriculture management practices is one of the way that we can reduce burning. And if you look at that burning, why is burning is coming? If you look at that, when mechanized harvesting is coming, especially combined harvesting, burning is coming with that. And we need to be careful in Eastern EGP. That's combined is coming now, and farmers now started to burning, and then we need to be wake up before create a problem. and that's we want to look at that. Conservation, biodiversity, and biofauna plants, that we need to be say more. When we'll recycle and do natural practices, we will definitely conserve our biodiversity. And if we adopt that, at least we can address 10 sustainable development goals, that food, water, and energy and access, in additional benefits of environment and human health as well. And definitely, if we do in large, that will give more economic boost to the country as well as to the region. And that's we call sustainable intensity. You know that conservation agriculture based is on 3 principles, and those 3 principles is minimal disturbance of soil, that we call no-till system, and that's here minimum disturbance, residue retention through crop biomass, how we can retain our residue in the soil, recycle of our whatever crop residues is there, so we can maintain our soil health, as well as we can reduce the evaporations, as well as maintain soil temperatures and get more benefit. Crop rotations, that benefits of crop rotation, that's it breaks down the disease cycle, distribute proper nutrient release, and then what we call that nutrient uptake, and these kind of things. That's 3 principles that we are talking, that will give more benefits to the economy, to the farmers. I'm coming, what are the benefits of 3 principles? If you look at that, what are the benefits of crop diversifications? If you look at the crop diversification benefits, that decrease pest, disease, and prices. And what is the crop diversification? Crop diversification is intercropping, is growing 2 or more crops at the time on the same piece of land. Crop rotation is growing 2 different crops on the same land in a sequence manner. Again, crop diversification is sometimes misleads, because sometimes we are growing rice and rice wheat. This is already complex system, and farmer don't want to change that system. So what we can do in that existing system, we can bring 3rd crop through intensification as a different kind of crop for nature, like legume or oilseed, and we can build, and then we can diversify it with intensification. That can be also considered as a diversification. And if you look at the benefits, it reduces the occurrence of pests and disease by interrupting the life cycle of pests and weeds. It's a weed controls by breaking the cycles of that. It was in rice weed system, there was a big issue of fertilization miners, and then we changed diversification, and then no-till, that was control on some extent of this fertilization miner. Adequately distribute nutrients in soil profile, because if we do crop diversification, we need to be include different root systems. So like tape root system, deep root system, shallow root systems, and that will take soil nutrients evenly from deep soil profile as well as from the surface soil as well. Reduces economic risk in case of an event negatively affecting certain crops. It maybe if we have a crop intensification, 3rd crop inclusion, maybe we will fail in 1 crop, then still we have a chance to get something from the next or intensification crop. Allows to balance residue reduction. Some crops leave more residue than others. So we need to think about that, which crop, if like wheat is using or rice fodder is using for animal, so we can retain more wheat, and vice versa. Similarly, where we are, if we go in northwest, wheat fodder is using for animal, but in eastern part we are using rice, storage of animal feed. Minimal soil suppression avoids compaction and soil surface sealing, reduce erosions, improve soil fertility and structure, increased biological, these are the minimum soil disturbance that we can, by no-till system. And then what is the benefits of soil coverage by, crop biomass? Higher water infiltration and available soil water content by reducing the evaporation and improving soil structure and organic carbon. Less evaporations by, covering soil surface, because then we can, reduce the evaporation from the surface. Less water and wind erosion, because if we cover soil, its soil is particle is less available to contact and for erosion to the wind and water. And then it's buffered soil temperature by 5 to 6 degrees Celsius, that improve the biological activities of the soil and increases biological activity and soil, organic matter with time. So these are the benefits of, 3 principles of CA. I would like to go back from what is the status and how conservation agriculture came in picture. If you go back especially for students, that in 1930 there was a big issue in Latin America and in US and then Brazil, that there was a dust balls. That's because due to intensive delays, that with cyclones and what we call that dust balls, lot of soil particles was moving from one place to another, and there was a big issue of in cities due to soil, what we call here also sometimes that from Rajasthan there are some desert or what we call that dust balls are coming and creates a problem. Same problem was in US, and that scientists work on that, how to mitigate and resolve this problem. And then one of solution was came in picture is that no-till system. Initially there was no adoption from last after started from 1950 to 1990. It's very limited adoption of CA in 40 years, but onwards to 19, the farmers understand the benefits. And if you look at that, it's skeleted like an aeroplane. It's speedy adoption. And nowadays, if you look at that, every year 10 million hectare annually CA adopted globally, and that's the good sign that now conservation agriculture coming in practice and scaling in large area. Though in India still we are working, and definitely in India our system is complex, so we need to be define conservation agriculture in a different way rather than stick with three principle. In total, around 180 million hectare it's area under conservation agriculture globally. But if you look at in India, around 2.5 to 3 million, I would say 3 million hectare under conservation agriculture nowadays. Recently, we cited this in our Nature paper that is coming in recently, that 2.5 million hectare, and this was captured by remote sensing and many studies. And you can see the adoption of India in especially Haryana and Punjab. This blue dot shows that zero tillage in wheat and legumes. But still we are struggling for rice. So if we talk about as a whole system conservation agriculture, I would say we will have very limited area. But if we talk about rice fallows in dryland winter crops, we have around 3 million hectares of area under conservation agriculture in India. And now this conservation agriculture coming big way in eastern part of India, especially in West Bengal, North West Bengal and Bihar and all. And we can see clear impact through SRFSI project that we implemented from 2014 to till now, and we can see significant adoption in this area. Why we adopt conservation agriculture? That's the first question came in mind of the researchers, policymakers, and farmers as well. So if you look at overall from our studies in Eastern Gangetic Plains from 3 countries, West Bengal, Bihar, Bangladesh, and Nepal, more than 350 on-farm farmers participated in research trials. And this research was managed by the scientists in partnership with all the farmers. So joint management of farmer as well as and we work with farmers, so farmers is also get confidence and they learn with that. So if we look at overall benefits of that, so it gives 5 to 10 penalty in rice, but much gain in next succeeding crops. It gives us and it saves 8 to 17% irrigation water, because water saving is less as compared to Northwest, because here we are growing more rain-fed crops, especially almond crops. So that's why water saving is coming less as compared to Northwest India. But it saves huge labor, 26 to 40% labor saving. It saves 46 to 62% energy, which coming through reduction in soil fuel, as well as reduction in tillage, as well as reduction in labor. So it's coming from out of these three, especially that's fuel, reduction in tillage, and labor, and machinery, and irrigation as well. And it gives 16 to 56% higher profitability depending on cropping system and diversification options, and it's reduced finally 11 to 16% CO2 equivalent emissions. Please let me know if I'm too fast or too boring, so I can adjust accordingly. Meta-analysis of performance of CA. This is, came in recently in Nature paper, and here we try to address that, because three principles defined by the FAO is mainly considering the mono or single crops in rain-fed areas. But in South Asia, we have a complex system. We have 3 crops or 4 crops in a year, and that's maybe it's difficult to imply all 3 principles. So here we tried and quantify that even we will not do full CA, even we will do partial CA, one crop in farmers practice or reduction systems of tillage, and next crop and no-till, still farmers will get benefits. And that's why we try to be, do that. But here we are saying that if you look at that conservation agriculture, and of 4 parameters: grain yield, protein equivalent yield, water use efficiency, and gross margins, and we quantify on farm, on station, and combined. And this paper came from like more than 300, 3,000 on farm trial data, as well as more than 300 studies, published studies. And if you look at that, grain yield, protein, all 4 parameters is perform better under conservation agriculture as compared to farmers practice as conventional practice. This is the baseline of farmers practice, and these are the improvement shows through conservation agriculture in protein. So it shows higher grain yield, higher protein equivalent yield, better water use efficiency, and higher net incomes. If we look at that, sometimes we will say, oh, conservation agriculture will work only in rice wheat system. It will not work in maize wheat system. It will not work in rice maize system, and in the legume crop based systems and all. And this paper is clearly shows that it works in all kind of cropping systems. If you look at that rice wheat system, rice maize system, maize wheat system, and legume based and oilseed based system, it perform equally in all cropping systems. So that's why that myth should not be there that it works only wheat, it works only for maize, it will not work for other crops. It works for all crops. It depends how we are managing. Now I'm coming, which is very interesting from this paper, that the performance of conservation agriculture, it also depends on soil type. If we look at that, in sandy soils, there is a mixed results. It gives negative as well as positive results. But in other soil types, if you look at clay loam, loamy and loamy, moderately coarse soils, in all soils it works very well except coarse sands. And why is this working in poor in coarse sand? Because this data also came from Northwest India, where rice is growing in sandy soils, which is not reponded. If we do DSR or no-till in rice in coarse soils, then there is a problem of water retention and water holding, and that gives yield penalty in rice. And that's why it's showing in coarse soils as some negative results due to rice, not due to winter crops like maize, wheat, and legumes and all. So that's the results, and that scientists need to be work on rice to develop a aerobic varieties that will fit for coarse soils and fit well, and that will give good results in that situation as well. So we need to be work on that, and maybe in future we'll get resolve this issue as well. This is a recent paper again come, and then especially I will talk on Eastern Gangetic Plains here. So if you look at that rice yield, so rice wheat system is not recommended for eastern part of India. It's not profitable. It's not produce enough as compared to rice and other cropping systems. But if you like to make this rice wheat system as more sustainable and more what we call that improve productivity, we have to think about third crop as rice wheat jute, rice wheat moong, some kind of innovation. So if we combine with rice wheat jute, rice wheat productivity is gone up immediately, and that's more profitable. And that's jute is so as a nice crop that's restore our soil fertility as well as deep root system as well, and it improves soil health. And that system is well suited for West Bengal, and that is going away slowly from the farmers. And there are issues with like due to returning and rating and all, but that can be resolved. And but this system is very good if you want to sustain rice wheat system. Rice system is good productivity, but is not sustainable. I will come in next slide. Why is not sustainable, but in terms of water and energy. And if you look at that, rice lentil system is perfect, but problem with rice lentil system sometimes biological stresses, especially disease and all, and that's always as a challenge. So we need to work how to mitigate those biological stresses with new inoculums and kind of like other management strategies, and make more profitable this system as well. If you look at that total energy use, I told why rice system is not. If you look at that in terms of energy use, rice system is heavily or energy intensive system, which is not sustainable for future probably. So we need to work that how we should not suggest that boro should be placed everywhere, but boro should be diversified from uplands and continue in lowlands, and where water is stagnation and water issue is not there. But it should not be cultivated in uplands where land is there and like barren tracts and upland soils and all. So that's we need to be work on that and look at that very location specific cropping system, which will suits in which conditions, and that's we need to be work on that. Rice maize system is coming as a kind of like most effective. If you look at that, rice maize system is not that much of energy intensive, but it gives less CO2 equivalent and also more profitable and more productivity as compared to rice and rice wheat and other cropping system. So this could be a potential cropping system for Eastern EGP, and that's coming big way recently. If you look at in Eastern trends and pattern of maize areas, it's increasing every year. So this is labor. Again, that's if you look at that rice wheat from conventional to conservation agriculture, it's from conventional to conservation agriculture reduced significantly labor use in rice wheat, rice maize, and rice lentil, all three systems. Similarly, gross margin is increased in all these three cropping systems. If you look at gross margin is increased by adoption of conservation agriculture, and in rice maize also further increase, and is also if we combine diversification and conservation agricultural practices together, then it will give from here to here, from rice wheat and rice maize. So that will give more benefit to the farmers. If we layer that diversification as well as conservation agriculture together, then it gives better returns. This is meta-analysis again from 10 indicators that we already discussed. And then system rice equivalent yield, that's I'm talking SREY, changes in energy, CO2 equivalent emissions, and change in productivity. Here T2 is partial conservation agriculture. It means rice is growing in farmers practice and following crop is growing under no-till system. So still this gives benefits in terms of productivity. It's little less benefit, but still there is a benefit. But if it T3 and T4 are full CA, where both crops or three crops or whatever 4 crops we are taking system, all are under no-till, under conservation agriculture, following 3 principles and all, and that gives additional benefit. So depending on the farmer, so we should give to the farmers options, and farmer will choose according to their suitability and according to their compatibility and capacity. So we should give the options to the farmers rather than we'll push to the farmers whatever we want rather than what they want. So we need to give option to them, and that will choose by the farmer, and maybe they will pick up sometimes full package, sometimes they will pick up one or two part technology part of the package rather than full package according to their suitability. So it gives higher yields, it gives less energy use, reduce in energy use, it gives higher product energy productivity, and it's reduced CO2 equivalent emissions. Similarly, it gives saves water up to 40% depending on cropping. It gives total water saving. That's total irrigation, and total means that includes rainfall as well. Change in water productivity, it's better water productivity, reduction in labor use, and change in production cost. If you look at that, it's reduced production cost significantly by 20%, and change in gross margins, it's increased by 20 to 30% margins. So if we still use partial CA, it gives 15% higher net income to the farmers. But if you adopt full CA, it gives up to 30 to 25 to 30% higher net income. This is, if you look at that, most of the studies previously published, if we increase the management level, if we increase the intensity, if we increase the tillage intensities and all, and management as well, it's also increase the global warming potential. But this is the paper published, in Global Change Biology from our Karnal, that we have a big platform we established, and it clearly shows that if we do farmers practice, it's global warming potential is higher if you want to improve the productivity and income. It also gives higher kind of global warming potential. But we adopt full CA, and then future cereal system is that diversification with CA with diversification, it's reduced 62% global warming potential with reduction in management, and we will get same level of higher production and higher income, and that gives global warming, and that can be achieved only by adopting the CA. If we look at this giving further, so it shows that with the adoption of zero tillage or conservation agriculture, we can achieve higher productivity and higher net income with less CO2 emissions. And that's the beauty of conservation agriculture, that we can reduce CO2 emissions and we can get higher production as well as system net income. And that shows for rice, wheat, and rice maize system. In both systems, same trends are coming. Now I'm coming to climate risk. How is that? If you look at, we studied in leaf water potential as well as photosynthesis. And if you look at that, where we have a no-till with residual retention, it gives better leaf water potential. So leaf water potential is low because this is negative. So it's lower as compared to where we don't have a residue. So residue is also helps to provide better water, and plants looks happy because water is available for plant uptake, and then leaves are always turgid and more happy, more watery, and then plant will not see any wilting in the leaves, and then that's why that's trigger pressure is always higher in leaf as compared to where we don't have a residue because it's less water. Similarly, photosynthesis rates are also higher under where we have a residue retention as compared to no residue retention. So residue retention is also very important when we want to do conservation agriculture. If we don't have a residue retention, then it's a problem. This is very interesting figures. We monitor this canopy temperature that shows the microclimate temperature that within 1 meter of of the plant environment. And if you look at that, when we have a terminal, it's at the time of maturity. When we have a, where we have a residue retention, you can see plots, those who are more greener, those are with residue retention, those plants already are matured, those are residue removed. And why is that? Because here more water is available, and that's water is available, so its plant is transpire more water, and that transpiration keeps microclimate cooler, 3 to 4 degrees Celsius, as compared to where we don't have a residue and we have a conventional practice. And that will help to terminate, to mitigate with less, heat stress or terminal heats, where we have at the time of maturity. And that's the beauty of conservation agriculture, that can be mitigate up to some extent of terminal heats of wheat. If we look at that, this figure is a compare of rotavator, which is coming very big way nowadays without promoting of the any institutes or universities and all. And this is happy seeder. And this slides and picture came in 2015. There was a big rainfall event in Northwest India in Haryana. And there was a like around 80 mm rainfall in one day. And there was a huge waterlogging in the farmers' field. But those farmers adopted CA and adopted the happy seeder. There was a high infiltration and percolation, so there was no water stagnation. But those farmers adopted rotavator, and there was a waterlogging, and crop was burned due to waterlogging. And you can see clear picture, right? That's there is no crop damage here, same plot, same field, but here you will see a lot of damage and crop was burned due to excess water. But our policy sometimes is make difficult to the farmer. So here that government announced that those as a kind of incentives as per what we call that crop damage. So those farmers adopted rotavator, they got more incentives, but those farmers adopted green technology, they didn't get any incentives. It should be vice versa. Those farmers adopted green technology, they will get better incentives rather than those farmers adopting dark or red technologies. So that's we need to think about policy aspects, but this is happening. So maybe you will not see that conservation agriculture effect or benefits in good year, but when bad years will come, then you realize that how conservation agriculture is important. This is another paper that's come, that's how conservation agriculture gives better probability, and CDF, and that gives like again same studies come published, and it shows that where we adopted conservation agriculture, it gives better profitability in all levels as compared to conventional systems. You can see it. This is the picture from the same day. Only difference here is noted, here is conventional. You can see this plot is getting, level is also higher, but there is no water stagnation because higher percolation and infiltration. Here water stagnation is there, and this crop will be suffered. This is from Punjab, Ludhiana, from sandy soils. You can see that even sandy soils, so that water stagnation is there. This is a study from crop lodging, happy seeder versus rotavator. And if you see at the time of flowering and in different districts of Haryana and Punjab, and you see that where we adopted the happy seeder or conservation agriculture, there is a minimum lodging was observed, but where we adopted rotavator, lodging was up to 60% or 70%. Why is that? Because rotavator, till very nicely fine, but it makes 2 to 3, centimeter below hard pan layer, and that's restricted to the root growth. Crop looks very good initially, but at the time of maturity, if there is any stress of drought, or if there is any excess water, crop will burn, and then you can see lodging. But in happy seeder, there is a very good, what we call that rooting system, and you will see less, lodging. So these are the studies. It clearly shows that how conservation agriculture can, help to mitigate under adverse climatic conditions. in terms of drought as well as in terms of excess rainfall or storms and all. Look at that maize. Here is that maize under no-till system permanent beds, but here it's again fresh beds in conventional system. Water is stagnant, maize is almost dies, but maize is still stagnating very well here. Same, you can see that's from this picture. This is DSR versus puddle, and here this is DSR in Bihar, in Pusa. That's in 2014 there was no rains and there was a dry spell, but still farmers get something from where they grown DSR, but there was transplanted and there was no rain and farmer couldn't apply much water because pumping water is high, very costly, and farmer cannot afford, so crop is like almost damaging. So these are the examples that we can show these conservation agriculture practices more resilient. This is again another example, zero till without residue, zero till with residue. You can see this is from Bisa, Ludhiana, and you can see maize how it's performing with residue and without residue. So residue helps us to retain soil moisture and all, and plants are more happy. I will come on that when we'll continue long-term benefits of CA. So this is like recycling of residue in last 8 years and how soil carbon is improved from 0.4 to almost 0.8 degree, 8%. But this is not profile carbon. This is surface carbon only. So maybe if you study the profile carbon, you will not see that much of significant effect, but still there are benefits, you will see. So it improves soil carbon at surface with time. There is no, if it improves, NPK, and it's also improves soil pH, but more interestingly, it improves soil quality index, SQI. And if you look at that, where we have a conservation agriculture, it's green, it improves significantly as compared to business as usual in, first scenario. And that gives, higher organic carbon, nitrogen, phosphorus, potassium, and better SQI. SQI is a reflection of all soil physical, chemical, and biological properties that you get. And this paper published in 2018 in Soil in Catena, maybe you can get. It improves, infiltration rate and with time. And this is the paper published in 2011 from Modi program long-term trial, where we have conventional system, it reduces the infiltration rates, but where we have no-till system, it improves infiltration rate. But doesn't mean that improvement in infiltration rate is good for rice, definitely good for wheat, maize, and legumes and oilseed for rice following crop, but not necessarily sometimes good for rice, because rice loves water stagnation, soft environment. So we need to work on variety which perform better in aerobic conditions of rice rather than in that, and that's we are working. If you look at all soil penetration, where we have a conventional that creates soil surface, below flow pan, and that gives higher, resistance. That means it's create a impermeable layer as compared where we have, conservation agriculture practices. It gives better soil temperature. If we look at that, this figure clearly shows this is morning, this is evening, and this is, look at that conservation practices, and this is conventional practices. Temperature taken every day from the beginning day of the seeding to harvesting. And if you look at that in morning in conservation agriculture, soils are warmer as compared to conventional, but in evening these trends are opposite. So soils are more cooler in evening as compared to conventional system. So it's buffered 5 to 6 degrees Celsius at soil surface, and that gives better environment for soil biological and enzymatic activities in the soil. And that's beauty of keeping residue on the surface. And if you look at also soil metric potential, it clearly shows that where we have residue, it gives better or less soil metric potential as compared to where we don't have residue. So it shows that more water available in the soil as well. This is kind of least limited water, range. And what is the least limited water range? This is the reflection of soil physical properties in a kind of a index way, and that can be calculated by like water content, at percent volume at 10% aeration porosity, or critical moisture at 10, minus 10 kPa, minus water content at critical mechanical resistance of 2 megapascal. And that is study show that if like soil resistance is more than 2 megapascal, it's restrict the soil, plant root growth. So that's why we consider as a critical, or maybe what we call that limit of 2 megapascal, and that gives limiting, least limiting water range, and that gives better under no-till system as compared to conventional system. If you look at that, these are T1, T2 are the conventional system, T3, T5, and T6 are the no-till system, and these are the hybrid systems. And that gives clearly shows that water limiting is better under no-till system as compared to that. It's also improved soil enzymic activities and soil microbial activities. If you look at that dehydrogenase activities, so microbial and biomass carbon, active phosphate, activate and microbial nitrogen as well, biomass, and all are giving under better under conservation agriculture system as compared to conventional system. Hybrid system is better here because when we do again incorporate after zero place that residue in soil profile or maybe in soil surface, that gives better activities of this dehydrogenase and microbial biomass and nitrogen biomass and all. And but that's gives better activity in conservation agriculture. It also improves bacteria, fungi, and actinomycetes. We have further details which beneficial bacteria and fungi and actinomycetes, which groups are increasing and improving in conservation agriculture. But here we are resting that it improves bacteria by 26 to 28%, fungi by 61 to 68%, and actinomycetes by 92 to 98% population as compared to conventional system. It's also a very good example that when we have a conventional versus conservation agriculture where we have residue. So what we did, we put counted weed seeds in soil surface in both plots, in conventional as well as in no-till where we have a residue. And we recounted again after 2 or 3 days. And we found that most of weed seeds disappear where we have a residue, but there is no seed disappear or very limited seed was disappear under conventional system. So it shows that in conventional versus in conservation agriculture, the weeds disappear more in conservation agriculture by predators. So there are many ants, micro and macro orthopods and all that's predates the weed seeds, and that's why we are saying if we maintain and control weeds properly in 1 or 2 years, after 2 years we'll see the significant reduction of weed population in conservation agriculture as compared to conventional system. There are strategies for scaling and adoption of CA. Dr. Abbas, please let me know time. I think I maybe take 10 minutes more. It's okay. So
Maheshji, it will be better if you could reduce it in 5 minutes.
Okay, I will do that. Okay. So strategies for scaling and adoption of CA. So there are many myths, for philosophical perceptions that we have mindset that okay, conservation agriculture works only wheat, not work for rice, maize, and lentil and all. It works on only for rice feed system. It works only in sandy soils. It will not work in that. So there are many myths, that's around. But that myths are wrong, and that's paper came from Dr. Sharma, A.R. Sharma. It's almost like 20 myths he described very well. And these all are myths. There is no relation with, reality. And research articulation and targeting, we need to be work on that. blanket recommendation, rather than we will define or fine tune our research according to areas, according to cropping system, according to farm typologies, so on so. Definitely, we need to be more work on development and infrastructure for especially manufacture, access to machines, spare parts, repairing of machines and so on. So knowledge and capacity is very important, especially including of the curriculum of PhD, masters, and UG program, which is very important. So we can give the knowledge to our new generation about conservation agriculture. And finally, policy and investment is very important. And so I don't want to go in details of philosophicals and all. So several myths around that. And Dr. Sharma paper is available. If you want to go in detail, you can see. Definitely, we have to work on participatory, evidence and recommendation domains. What works where and what doesn't works, and what doesn't works, we need to be refine our technologies and fine tune our technology. We cannot recommend blanket. That's okay if zero tillage works very well in Haryana, Punjab, doesn't mean it will work very well in West Bengal. It needs maybe some refinement and fine tunes, and then it will work very well. One side doesn't fit all. So we need to be give our recommendations on domain based, on cropping system domains, on soil types, on land typologies and farm typologies and so on. So yeah, I already talked about circumstances and how we need to be articulate circumstances, that about we need to be work on where and what circumstances our CA works and what circumstances doesn't work, and we need to be fine-tuned accordingly. We need to be work more and believe on science-based recommendations on CA or whatever technologies, rather than just on believing that rotavator works well and it looks good, but what are the scientific evidences behind on that? So our policies should be always on science-based, and revisit of principles of CA according to our South Asia. Doesn't mean that we will stick with FAO3 principles. We need to be work according to our situations, and locally adopted technology, seed variety, nutrient, and weed. We need to be work around that's on component trials and on management. Doesn't mean that because maybe management is required different and conservation than conventional system. Development of infrastructure, I already told that we need to be work on manufacturers and access, repairing, workshops, trainings, and so on and so. And CA's curriculum, that we works on that CA course in universities, and and capacity building on advanced courses is required. And good to know that now UBKB is leading for in Eastern Ghats Plains for like training centers. And that will be unique in India as well as in this part of, and that will be very helpful to scaling in future of capacity building. We need to be work on science-based evidences that this farmer looks showing that how rotavator is compacted soil, and farmers itself realize that it's not good for long term, and that will helpful, that visual syllabus and small learning and experience of farmer and sharing, that will be very helpful. Long online courses will be very helpful, that as well. That's like MOOC test, like massive online course to give more information and improve and make like capacity building of young farmers, manufacturers, policies, scientists, and so on. So through online courses nowadays we are working on online. Advanced courses I don't want. We need to work on policy, which is very important. I don't want to give that. These are the policies that is recommended by many agencies and by ICR, and then TAS, CIMMYT, international and national organizations, and so on. So I will give some time on that. 1 minute. Business models for, if we want to make success on scale any technology, we must have in place a business model. And this is the best business model which I have experienced, which happened in West Bengal, in North Bengal especially. That's farmers clubs, where all stakeholders come together and implement their technologies through these clubs. And these clubs is providing all seed to seed services through single window services, through market, seed, fertilizer, technology, customized services and so on. So that will also provide the employment to youth, as well as also give better opportunity to youth, and then better opportunity to the farmers as well. So we need to work these kind of models in future as well. We need to be work on long-term processes, science-based evidence that we need to be generate, participate on farm validation and refinement, backward and forward integration, component technologies, varieties, nutrient, water, etc., and multidisciplinary CA in agriculture, not just agronomy and engineering. It has to be all disciplines, even social scientists, behavioral scientists, pathologists, entomologists, engineers, agronomists, breeders, and so on. We need to work together. Science evidence-backed policy need to be in place rather than in believing on emotional-based policies. Science of scaling business models and scaling inclusivity. That's I talk, and capacity development must be in place through training and training centers and vast course and all. So that is my last slide. CASI improves system rice equivalent yield, water use efficiency, energy use efficiency, labor use efficiency, and gross margins for smallholder farmers with additional benefits of environment and all. CASI can contribute to sustainable development goals for food, energy, water. Nexus with additional benefit to environment resilience and social prosperity, provides opportunity for rural youth employment and women empowerment, need to be adapted to local farming system and environment geography. Institutional capacity and linkages are more important because we cannot work in isolation. We have to be linked globally as well as nationally, as well as regionally with all institutes where those are working in different aspects. And we need to be working in coordination. I need a strong governance and policy support to ensure full benefits of success of CASI in this region as well as globally. Thank you very much for giving this opportunity and bearing. I took maybe extra time, 20 minutes. So sorry for that. Thank you very much, Dr. Abbas. Over to you for question and answer.
Thank you, Maheshji, for your very nice presentation. Actually, what you presented is the practical, is a blend of practical and the research, isn't it? The whatever experience you have gained till now, you disseminated to us. So any questions from the students, please feel free to ask him.
Yes, sir. Yes, sir. Sir, hello. Hello,
Yes,
sir.
please introduce yourself and then talk.
Sir, my name is Somaresh Shao, PhD research scholar, Uttar Bishwavidyalaya. Very nice and informative presentation, sir. Sir, I have sir, one small query. Sir, is there any short-term effect of conservation agriculture on enzymatic activity rather than dehydrogenase enzyme? Hello, sir.
It depends again on cropping systems and on how we are adopting conservation agriculture. It's very difficult to see in very short, in one season or two, but in 1 or 2 years, yes, you can see some effect on enzymatic activities, and also depend what we are adding to the soil, organic matter and carbon, and how we are using these pesticides and all as well, herbicide. So depending on soil types and it's environment
in our situation,
so
sir.
In West Bengal,
in our yes.
I would say it's very difficult to see in immediate, in 1 or 2 seasons. At least you need 2 years to see some effect.
Yes, sir. Yes, sir. Yes. Okay, sir. Thank you.
Okay. Next, anybody else?
Hello, sir.
Yes, Subhadeep, go on.
Yes, sir. Myself, Subhadeep Mondal, sir. I am pursuing my PhD from Uttar Banga Vishwavidyalaya. Sir, thank you for the nice presentation. And sir, I have a question that SOC is highly correlated with the amount of crop residue added, and also the climatic conditions regulate the soil biological activities and the subsequent decompositions of the crop residue to contribute in the SOC fraction. So how can we identify or calibrate the ideal depth of crop residue mixing based on the cropping systems, or what the other parameters that we have to consider when we are talking about the contribution to the available pool of the crop residue mixing?
Again, uh, definitely what we add in will get same, outcomes. So whatever quality we add or recycle in soil, we will get that, quality outcomes as well. So we garbage in, we'll always get garbage out. So like we will do more tillage and all, we will mineralize and expose, definitely do. But, it depends what kind of quality, residue we cycle. So it depends also that it mixed with the, like cereals as well as legumes with crop diversifications, and then recycled, maybe more beneficial in.
Maiji, I think you are not audible, somehow disconnected. We'll wait for a few minutes. We'll just wait for a few seconds if he can join, because there is some problem in Bangladesh regarding the current. He's connecting. His internet is a problem, so he's connecting just now.
Yes, sir. Sorry, I am, back now, because sorry for that, because my internet is creating.
It's all right. It's all right, Maiji. No issue. So, any more questions? Please, you can feel free to ask.
Yeah, I'm back.
Okay, I will not now ask our Dean Faculty Agriculture, Professor Dibyendu Mukhopadhyay, if he has any queries regarding this.
Thank you, Maheshji, for your very nice and elaborate presentation. It has not only enlightened the students, but we, the faculties, are also enriched by your work. Just one thing I want to hear from you. that as probably you have also visited the North Bengal, where the farmers clubs you have mentioned, they are working very nicely on conservation agriculture. But the thing is that here there is shifting of the traditional system of cultivations, mainly the rice is now shifting on the rice wheat or rice maize cultivation, and the soil is sandy to sandy loam in texture. But the thing is that in the southern part of Bengal, you see there is the intensification of the rice cultivation. Rice is more dominant compared to the rice wheat or rice maize cultivations, and the soil is somewhat clayey in texture. There is water stagnation is there. So as there is so much advantages on adoption of the conservation agriculture, so in that provinces, I am talking about the southern part of the Bengal. If you want to introduce this conservation agriculture to the farmers field, whether there may be some means in terms of the adoptions of the technology, what should be the perspectives? I just like to know from you.
Thank you very much. So far, because I couldn't catch completely your question because of some breaking, but you are asking that in sandy soils in Northwest Bengal, conservation agriculture is how we promote and through these farmers clubs, and how is it advisable to the farmers, something like that, right?
No, actually he's asking that what will be the position if we go to South Bengal where the texture is heavier, and how to adapt this, because we have already you have already seen how we are adapting here. So he's asking what about the areas where there is more heavier texture in soil and how the problem of machines may come up. So he's asking regarding that.
Okay.
There is a rice intensification. So specifically in Bardhaman, Hooghly districts, there are Nadia, there are rice cropping system. So what are the issues in adoption of?
That's very, and that's, I said that it depends, so which is very interesting in rice system where we can do conservation agriculture, which is very important one thing, right? So in rice, it's heavier soils, maybe we need a small fine tune or adjustment in machinery, especially in times, because where we have a more clay soils and heavy moisture, maybe we need to have a different kind of tines, little bit, modification in tine itself of machine. Another problem in where we have a rice, rice system or rice base system in heavier soil or low lying, always problem of excess of field due to excess of moisture. And in that condition, also we need to rethink little bit on machinery and mechanization part, because that also can help to advance our planting at least some days, at least week or 10 days. And that could be because if we till and then we wait for dry and then again till, rather than we can go for directly. But in rice system, we should promote mechanized rice transplanting, which can be avoid puddling, and that can be done directly either in no-till or in unpuddled situation. That can give better yield as well as also helps to farmers to reduce their production costs. But still, to the honest, we are not that much of comfortable in rice under conservation agriculture due to certain problems of especially weed management. If we talk about particularly in almond rice, and in almond rice, if we will adopt conservation agriculture, DSR is not possible because these areas are uncertain rainfall. If we plant in under DSR, heavy rain comes, our crop can be failure 100%. So there are issues, But once crop is established, DSR is do very well in these ecologies. But crop establishment itself is a challenge in these ecologies. So we need to be work accordingly, So where that maybe we will move instead of DSR, we should move maybe we have good results from Northwest Bengal from unpuddled, rice transplanting to mechanized planting, and that will be very helpful. That would be time, new direction for us to take lead. Definitely, there is no issue in rice, follow dryland crops or winter crops like wheat, maize, maize, legumes and all. Hope I addressed her at some extent.
Yeah. Maheshis, thank you. Now I will ask Dr. Ganesh Bonik to summarize this webinar session.
Good afternoon, all. Am I audible to you? Okay. So it is my great pleasure to propose the vote of thanks for today's session of this ongoing webinar series on contributing soil research and education, a way forward. So I must thank first our Honorable Vice Chancellor because without his help and constant encouragement, we would never be able to conduct such a program. And I must thank, my heartful thank is to the Dean Faculty of Agriculture, Professor Divendra Mukhopadhyay. He is also the head and the head of the department and coordinator of this webinar series for his continuous support and providing facilities to conduct this seminar session. And I must say thanks to the deans and directors of the university, the Dean of Faculty of Technology, Dean of Horticulture, Director of Extension Education, Director of Research, for their support and their encouragement to do this program. And the committee of this webinar series, the convener, Professor A.K. Sinha, the members, Dr. Sobhik Dev, Dr. Amit Tamang, Dr. Himal Kumar Tarafdar, all I convey my thank, and also the participants. So today it is a very tough job for me to summarize the lecture given by the scientist Dr. Mohesh Kumar Khatala. He is working as the senior agronomist for CIMIT, and he is based in Bangladesh. He has given a lecture. It's a very informative and very nice presentation on the topic, the research conservation towards agricultural production potential. So he has started his lecture by explaining the different aspects which are responsible for the food and nutrition security which persists around the globes, and how we can achieve the food security to provide the food for all and to achieve also the zero hunger. Now he has explained the different aspects on different aspects of physical, chemical, biological factors for improving the soil health and ultimately the crop productivity. How we can manage the different soil properties which ultimately can increase the soil health and ultimately give us the better yield. His lecture actually based on the conservation agriculture, but he has said that the CA does not mean only the zero tillage or the no tillage. Rather the zero tillage is the one aspect of the several things which are associated with the conservation agriculture. Our aim is to reduce the yield effects of the tillage on the soil and environmental system, and to increase the sustainable productivity system. The CA is actually aimed to reduce the tillage to cause the minimum disturbance on the natural systems. It is true that the CA should be viable and economical to farmers to convince them to adopt the conservation system over their long-going conventional system. This should be. He has explained how can we make them convince how it could be better, viable, and economical for the farmers to increase their yield so that they can shift easily from the conventional system to the conservation agriculture. So he has given another aspect which is very important today. That is stubble burning. Stubble burning, that is a very important environmental issue persists in the northwestern part of the India, and it is creating a havoc in the environmental problem. And he said that the CA can be used effectively to reduce the stubble burning by reusing the stubbles as the crop residue in the conservation agriculture, which ultimately can improve the soil health as well as the soil productivity. CA provides a great opportunity to transit toward sustainable development system without harming the natural system. The CA is it is a good sign around the world that since 2009 the CA is increasing at the rate of 10 million hectares annually. In India also it is increasing around 2 to 5 to 3 million hectares annually. He has explained the different benefits of CA and why we should adopt the CA over the conventional agriculture, because it can increase the yield, it can save energy, it can save irrigation water, it can save labor, and ultimately reduce the carbon emission. The CA, we have general perception that CA can be adopted only for the wheat, but no, it's not only wheat. CA can effectively be adopted for the rice system, rice jute system, and legume based systems also, and it could be beneficial. He has explained about these different aspects. In West Bengal, CA could be adapted to increase the yield and soil health also in the rice jute systems. The global warming potential intensity could be reduced by reduced from 62% to 18% by adopting the conventional agriculture. He has explained that different aspects of happy seeder and rotavator to reduce the crop lodging and increase the yield, and different aspects of CA, adoption of CA in the different extreme weather conditions, like in the heavy rain, like the drought situations, etc. And he has established the superiority of CA over the conventional system for benefits for buffering the soil temperature, conserving soil moisture, and improving the soil biological property, etc. Lastly, he has proposed the different strategies and for scaling up and adoption of the conventional agriculture in the farming systems, as well as to convince the farmers to adopt the conventional agriculture over the conventional systems. Thank you, Moez ji, Dr. Moez. Sir, thank you, sir, for your very nice and elaborate lecture, and we have been informed about different aspects of conventional agriculture. Thank you, sir. Okay, thank you all.
So Maheshji, we are very thankful to you. So we'll be ending this session. We'll be again meeting at 2:30 with another lecture with a very important resource person, Dr. SP Datta from IRI. So, again, thank you all for joining this webinar, and thank you, Maheshji, for again thank you from Department of Soil Science and Agriculture Chemistry. Hope to meet again. Stay well, sir. Thank you, sir.
Thank you, everybody, from my side as well, for giving this opportunity. Thank you very much.